Hey, what's up, Marauders? This is video 4.5, concentration of solutions. In chemistry, it's not just important what the solution is, like you could have sodium chloride dissolved in water, but it's also going to be important how much sodium chloride is dissolved in the water. So what's the ratio of solute to solvent or solute to solution? There's many different ways to measure the concentration, but by far the most important one in chemistry is going to be this one, molarity. So molarity is how many moles of solute you have divided by how many liters of solution there are. So it's a ratio between how much solute, typically it's some kind of salt, dissolved in how many liters of solution. It's typically in aqueous solutions, but this works for other solutions as well. But the majority of the ones we'll look at are salts dissolved in water. So there's two different ways you can write out molarity. The capital M is a symbol for molarity, and that capital M is interchangeable with moles of solute over liters of solution. So we'll take a look at a couple calculations. The first one here says calculate the molarity of a solution with 35 grams of sodium chloride dissolved in 125 milliliters of solution. So we know that molarity is equal to moles of solute, in this case NaCl, over liters of solution. Okay, and right away in this problem, it already gave us the 125 milliliters of solution. When you're calculating molarity, the volume always needs to be in liters. So the volume in liters is going to be 0.125 liters of solution. And then we need moles of sodium chloride. We're given grams of sodium chloride, so we'll need to convert that from grams to moles. So we have 35 grams of NaCl. We'll change that into moles using its molar mass. So 58.5 grams of NaCl for every 1 mole of NaCl. And that's going to give us 0.598 moles. Okay. So we have 0.598 moles of NaCl for every 0.125 liters of solution. And when we divide that, we find that the molarity is equal to 4.78 moles of NaCl per liter. More commonly, you'll write it out like this: 4.78 molar NaCl. So that means 4.87 moles of sodium chloride per every liter of solution. Usually we just write the symbol with the capital M. Here's another one, solving for a different variable. How many grams of potassium chloride would be required to make 50 milliliters of a 2.7 molar solution? So 2.7 molar means the same thing as 2.7 moles of KCl for every 1 liter of solution. All right, so I'm going to change my 50 milliliters, since we always want liters to be our volume when we're working with molarity. I'm going to change that to liters, so that'd be 0.05 liters. And then I'm going to multiply that by the molarity, 2.7 moles of KCl for every 1 liter of solution. The liters will cancel out. Now we have moles of KCl. And then once we have moles of KCl, we can change that into grams using the molar mass, which is 74.6 grams of KCl for every 1 mole of KCl. And when we multiply that, you get 10.1 grams of KCl. The moles of KCl cancel out, and that's grams of KCl left at the end. Another useful formula when you're doing molarity problems is this one for dilution. Frequently you have a concentrated solution and then you dilute it or you add water to it to make it less concentrated. So this equation right here, M1V1 is equal to M2V2, is the initial molarity and the initial volume. Multiplying those together will give you the new molarity times the new volume. So this works when you're diluting a solution with water. And it's a fairly common procedure in chemistry labs. So in this question, we have 50 milliliters of 2.3 molar HCl, and it's added to 250 milliliters of water. What is the concentration of the solution? So we have a concentrated solution, a small amount of it, and then we add a lot of water to it. So we're diluting it. It's going to have a lower molarity at the end. So we're doing M1V1 is equal to M2V2. So you're always going to use this equation, not when chemical reactions are taking place, but just when we're adding water to a solution and diluting it. So your starting molarity is 2.3. And your starting volume is 50 milliliters. When you're doing this equation, it doesn't matter if you have the volume in liters or milliliters, as long as it's the same on both sides. So we have the starting molarity, the starting volume. And then if we have 50 milliliters of solution and we add 250 milliliters of water to it, we combine those two, we have a new volume of 300 milliliters. And then we can solve for the new molarity. We know the new molarity is going to be less than the original molarity because whenever you dilute a solution, you can only reduce the molarity. You can't increase the molarity or increase the concentration. So we use algebra to solve here, and when you do that, you find that the new molarity is 0.383 molar for HCl. Here's one more practice problem. What volume of 1.7 molar solution is needed to make 250 milliliters of a 0.5 molar solution? So maybe we have a stock solution in the lab and we need to dilute it to 0.5 molar for a lab, and we want to make a total of 250 milliliters for the lab. So how much of the concentrated solution should we start with to end with this volume and this concentration? So again, it's a dilution problem. M1V1 is equal to M2V2. So the starting molarity of the concentrated solution is 1.7. We don't know what volume of that concentrated solution we want. The ending molarity is going to be 0.5 molar. And the ending volume is going to be 250 milliliters. And so we'll use algebra to solve, and you get V1 is equal to 73.5 milliliters. And so what that's telling us is that we need to measure out 73.5 milliliters of this concentrated solution, and then we'll add water until we get a total volume of 250 milliliters, and that new diluted solution will have a molarity of 0.5 molarity.